We're going to build a very basic composable that interacts with an API and learn a lot of really cool stuff along the way. So let me give you an idea of what this is going to look like first. I want to have something like this: const to-dos indexer. And then that's going to be created with something like this: use index resources. That's going to be the name of our composable. Next, we're going to be able to type this by sending through to-do, something like that. And then we'll have like a to-do interface. And I'll just do this inline for now. Interface, to-do, and it's going to have a name, which is a string. And we're going to get this from a free API endpoint, which is called TypeScript. So I'll show you what that looks like. This is the name of the endpoint. Const endpoint is equal to that. So you can have a look at that and type that into your own browser. And basically, this just gives us some sample data that we can use. So it'll have a user ID and ID. So let's go ahead and add those in. User ID, ID, and whether or not it's completed. And that shouldn't be name, that should actually be title. So let's go ahead and change that to title. Okay, so we want to be able to say to-dos indexer, which is using this use index resources composable. We say, hey, the thing I expect to get back is a bunch of to-dos. And then we also want to be able to send our endpoint in as well. So for example, to-dos. By the way, there are some slightly better ways that we can do this. For example, the way I like to do it is actually send through a class of a to-do, which already has the name of the endpoint on it. But just to keep things simple in this video, we're going to do it this way for now, where we tell it what we expect back and then give it the end of the endpoint. Okay. Now next, I want to be able to do some cool options with this as well. So as a second parameter, I want to say, for example, immediate is equal to true, and maybe that will do for now. So here's the cool part, and this is what this video is going to be mostly about. We want to be able to pass through not only a static string here, but also a ref or a computed. So for example, right now, endpoint is a static string. So, oh, sorry, not endpoint. Let's say, const, let's call this entity. That's probably a better name for it. So we could say entity is equal to to-dos. Might just comment that out for the moment. And then we can just pass it through like that. But another thing I want to be able to do is say ref is equal to to-dos. And that's still going to work. So basically we can pass through here a string, or we can pass it through a ref of a string, or we can pass it through a function which acts like a computed. So for example, we can just pass a function through like this and say entity.value. Now, that's not a great example because, we could just pass through the ref in this case, but it means that we get some incredible flexibility here. We can essentially use a computer to figure out what the entity is going to be. And behind the scenes, what would happen is this function would be turned into a computed. So rather than having to do something like this and calling a computer like that, we can just send through a function and this automatically is like a reactive computed. Really, really cool. A great API. It gives lots of flexibility to the user. So especially if you want to start using APIs like this throughout your entire application, or I should probably use the word composables. So if you want to use composables like this throughout your application, it's great to offer that extra level of flexibility. And I'm going to show you how you can do that in a pretty easy way. All right, let's go ahead and build this. I'm going to get rid of all of that for now. We might actually keep this to-do part. How about I do a reveal here, create a new file in here and say to-do.ts. And then I'll come back here and grab that interface. We might actually cut that and we'll just export it like this. So we've got that interface ready to go. Now, let's go ahead and build out the composable. We'll create a new file in here and we'll call this use index resources.ts. Export, and I'm going to grab the name of that. Actually, I think I created a really cool, what do you call it, snippet for this. Called it like composable or something like that. Yeah, there we go. And it uses the name of the file to create the composable. And now what do we want to return here? Well, we probably want to return a function called index. So we'll have an async function, index, and basically that function is going to perform the index. So we return that back so that when we say, for example, to-dos indexer, just want to show you. So this is how we would be using it in the real world. We'll then be able to say to-dos indexer .index, right? So the stuff that gets returned here is essentially the stuff we can then use in the composable. Now, we want to know whether or not it's indexing, so that in the template, we can say, for example, to-dos indexer.indexing.value. This makes it really easy to like add a spinner to a button, for example. Really, really helpful. And there's lots of other things we could add, like filtering, but we'll leave it at that for now to keep this simple. Now, next, as we described before, we want to be able to send through the thing that, the endpoint of the thing that we're indexing, or specifically the entity, so that bit at the end of the endpoint. Let me just get this URL back here. And so how about we call this const, maybe base URL? I don't know if that's the best naming for now, but that's what we'll go with. And I'm going to get rid of this to-dos part here, okay? That part's going to be dynamic. And now what we can do is say const endpoint is equal to a computed, and we'll return here base URL plus, and now this is the cool part. This is where we essentially want to grab the entity that was passed through here. So we say entity is equal to MaybeComputedRef, all of that cool stuff I was talking about before, where this can be either a static string, for example, to-dos, or a ref of that is to-dos, or a computed. All of that becomes possible because of this special typing here. And I'm using @viewUse/core. So you might want to go ahead and run something like pnpm add @viewUseCore. Or if you're using yarn, then that would be yarn. Or if you're using npm, you'd use npm. But that's the name of the package that we're going to use in order to get that TypeScript type. Okay? Now, this has a partner. MaybeComputedRef has a partner, which is resolve unref. And essentially what this does is it takes a MaybeComputedRef and it resolves it. So if we get a static string, we get the string of that value back. If we get a ref, we get the string of that value back. If we get a computed, we get the string of that value back. Let me make sure I'm explaining this a little bit better. So in this case, we'd say base URL plus resolve unref entity. And let's just type that. That's going to be a string. Okay, so let me just go over this again, because this is a little bit to comprehend. But if you understand this, it's one of the most magical things that you can use in the composition API. If I were to pass through to our to-dos indexer, const, let's call this entity. If I were to pass through to that to-dos like this, resolve unref would be equal to to-dos. Okay, so we would just basically get that value back. So resolve unref in this case would just give us that string back. It's not doing anything fancy. In fact, it's pretty much the same as just sending that entity through. It does basically nothing at all. However, if this is a ref, and then we run resolve unref on this, again, we get the string to-dos back. It's resolving that ref. Okay, so instead of saying add entity.value here, entity.value, we go resolve unref, and that gives us the result of .value. So if it's just a string, we get the string back. If it's a ref, we get the value of that ref back, and it also works with a computed as well. So if we were to pass through a function like this, entity.value, all right, so we pass through, imagine that this gets converted to a computed property behind the scenes, okay? So instead of sending through a computed, we can just send through a function because it's easier to write. So instead of having to do something like that, right, we're able to just send the function directly through. And in that case, again, it resolves that function, and then we just get back the string. So the magical thing that happens here is MaybeComputedRef figures out all of the typing for us, okay? So it figures out that this needs to be a string. So if I were to pass through there a number, all right, let's get ref imported here so this works. And we gave that a number. notice that this is not working. It's giving us a red squiggly. It's saying, hey, you've given me the correct, you've given me a computed yes, however, it's a string. So if we change that to a number, if we change that to a string, it's now working. And it's the same if this were just the ref. If we said, hey, let's just give it that ref value, and it's a number, it's fully typed, and the typing still passes through. And if we were to give it just a plain number, again, it's fully typed, and it doesn't work unless we give it the right kind of value. So this is really incredible. This is one of my favorite patterns with the composition API. From the user's perspective, from the person using this composable, from their perspective, they can send through the value however the hell they want. And the reactivity is kept. So if they send through a ref, it's still reactive, but we still get all of the typing, and they get to pass through the value however they want. It's really, really cool. All right. I think I've explained that to death now, but this is one of those things that's kind of hard to wrap your head around. So I wanted to make sure that I really sort of drilled through how that works. And if you need to pause the video right now would be a good time to play around with this MaybeComputedRef and get sort of a feel for how that works. All right, let's go ahead and continue building this. So we now resolve that entity value. Okay, we resolve what comes through there, and that's how we get our endpoint. And now when we perform the index, we can say, hey, I want you to use the fetch API to get the response. So the response is equal to fetch endpoint.value. And we'll do an await on that. And then we can say const data, or how about we actually store that data? We'll say const data is equal to a ref, and we'll make that an empty array by default. There we go. So now we can say data.value is equal to response.json. And we're not going to deal with any errors here, but as you can imagine, this is a pretty naive approach. You would want to make sure that you handle any errors by wrapping this in a try-catch, for example, or something like that. Okay, the next thing we want to do is know if it's indexing. So let's come up here and say const indexing is equal to a ref that is false by default. When you start indexing, we set that equal to true. And then when you're done indexing, we set that equal to false. And there we go. Okay, we also want that data returned here so that it's available. And now we have a way to index. We have a way to know if we're currently indexing. And we also have a way of getting that data back. And by the way, the reason we use the word index here is because that's what it's used in RESTful language. So a REST endpoint where you get all of the values. So in this case, we're getting all of the to-dos. That's called an index. So you might know it as fetching, getting all of the data. Basically, I'm trying to use terminology here that matches the REST protocol. All right, there we go. So we can remove all of this example stuff now, and let's go ahead and see if this works. What's the best way to do this? I might just go back to the index page, and we'll say const to-dos fetcher is equal to use fetch. Use index resources. I've gotten used to writing the word fetch indexer. So we have a to-dos indexer, use index resources, and specifically, I want you to get me back to-dos. Let me close that out. And then straight away, we're going to fetch that. Oh, actually, how about we put that on a button? We'll have a pre-tag here that says, hey, to-dos indexer, give me the data back. We'll have a button here, q-button, and we'll give that a label and set that equal to index. And then when you click on this button, we want to say, hey, to-dos indexer, I want you to go ahead and get those resources. I want you to perform an index. So there we go. We've got our button. And the other thing we want to do is know whether or not that button is indexing. So now we can say loading is equal to, hey, to-dos indexer, are you indexing right now? Save it. Let's run that. And there we go, it works. How cool is that? We get that beautiful spinner as well. And unfortunately, the results get cached, so we can't see the spinner anymore when I click on this because it's just too quick. But you get the idea. So there we go. That's working. However, there's one other thing I want to do. So I want to get the proper typing here. It would be cool if we could just have like a list. Let's maybe make that bordered. Maybe add some items and item sections in there. And let's say v-4 is equal to item in to-dos indexer.data.value. Now, the only problem with this is if I try to give this a key, for example, and say item dot, we don't get any auto completion here. And I want to get auto completion. In fact, I've been pretty obsessed with auto completion lately. I always want to know the data I'm dealing with. Now, this might not seem like a big deal right now, but if you're working with larger applications, this is an effing nightmare to work with. When you don't get that auto completion, especially as things get more complicated in your application, especially when you're tired at the end of the day, it's really, really frustrating. And it really doesn't take much extra work in order to get that auto completion. So let's go ahead and see if we can figure out how to do that. I'm going to comment this out for the moment. And let's come up here and we'll jump into our use index resources. Actually, before I do that, let's import that interface we built before. So remember we created this todo.ts file, which gives us an interface for to-do, which matches up with what we got from the endpoint. Now we can come in here and I want to be able to pass that through. Whoop, looks like Vola's not updating there. So let's import to-do from /to-do. Yeah, okay, the reason Vola probably wasn't working is we haven't actually added that generic in yet. So it's saying, hey, you're passing through an argument, but I don't expect to get any arguments because we haven't implemented that yet. So let's control click use index resources. And let's say we expect to get some sort of an interface here. So let's just call this, I don't know, entity. You might just go with that. I think I can make it that simple. And now what I'm going to do is say, hey, that data I get back, it's not just a normal array. It's actually going to be an array of entity. Okay, so the type that you pass through here, we're going to use that type to essentially say what this array looks like. And now we come back, we're saying, hey, I want this to be a to-do. Actually, let me just show you the flow of this. I think it will help. So we say, use index resource, I want you to get me back to-dos. And this is what I expect the shape to look like, the shape of that data to look like. All right. And remember, if I control click that, that's what that looks like. So now this to-do interface has been passed through to entity, okay? And now for the data we get back, we're saying, hey, I expect you to be a ref of an array of entity. In other words, an array of to-do in this case. So now when that data gets passed back here, okay, when we pass that back in the composable, all right, and this is where we receive it here, okay, that should now have the typing that we passed through. All right, I think I might have explained that to death, so let's go ahead and see if this works now. If it doesn't, that'll be a bit embarrassing. So the key is equal to item, or in this case, we can actually call this to-do. I like to be specific with my variable names, specific as I can be. And there we go. We now get full auto completion there. And this is an absolute joy to work with now. I can say to-do.title. And by the way, as I pressed dot there, I saw, oh, I've got completed as well. So let's go ahead and add another item section and make this a side item. And maybe we can have a Q-checkbox, and we'll just send through a model value for that checkbox, which is to-do.completed. There we go. Save it and let the linter do all the work. Whack that back over there. And there you have it. How cool is that? What an awesome and useful composable. And check this out. I'm going to change this back into a pre-tag. So I just did this because I wanted to show you the really cool TypeScript part of this. But now, let's just go back to using a pre-tag to see our data. And instead of a to-dos indexer, I'm now going to call this a resource indexer. So I'm genericizing the term. Or you might even want to call this an entity indexer. You can use whatever language makes sense for your project. I tend to use the word resource. So I want you to index a resource, which is me basically saying it might be a to-do, but it might actually be something else. Okay, that's what I mean by genericizing this word. Resource means it could be a to-do, it could be a user, it could be a post, it could be any kind of data. It's a resource, but I don't know what type yet. So now check this out. Const resource types, maybe something like that, is equal to a ref. And now remember the MaybeComputedRef stuff we were doing before? Because of that, this can now be a ref. I can pass through a ref there. So now I can say resource types, or how about this, sorry, const selected resource type. We'll make resource types an array, and one of them will be to-dos, and another one could be users. And now selected resource type is a ref, and it's going to be something in that array. So how about we do this? Export type, and we'll call this resource type. We'll set that equal to to-dos or users. And now we can say resource types is an array of resource type. And the selected resource type is basically one of these. It's either to-dos or users. All right, so I'm just kind of showing you how we can use TypeScript to make this a little bit safer. Now we can give that a default, and notice we get auto completion. So now we can say it's to-dos by default. And let's come down here, and for the selected resource type, we can use a QSelect for that. This stuff is just a piece of cake with Quasar. Well, that should be model is equal to selected resource type, and our options are resource types. So now it's to-dos by default, but then I can change that to users. And check this out. Because this is a MaybeComputedRef, it's going to allow me to also send through selected resource types. And inside of here, instead of saying just to do, I don't even know if this will work. Let's see if this works. We could say to do or user, and let's go ahead and open up this to do. I'm going to duplicate that. I'm going to call it user, and then let's go to type your code. And I think they've got one for users as well. Yeah, there we go. And okay, I'm not going to do all of that typing, and that'll be a bit too much. You can go ahead and do all the typing if you'd like to. That could be a fun activity. And how about this? We get ID, name, username, email. Let's get rid of everything in address, and everything in company as well. All right. And these are all strings, so that should be easy to type. So say string there, just fix that up, and we'll fix that up. And then the ID is going to be a number. And of course, this isn't a to-do, this is a user. So now we've got a type for our user as well. And now we can come back here and say, I expect to either get a to-do or a user. All right, so let's just copy paste that down because I'm not getting auto completion there. And there we go. How cool is that? We've now got a useIndex resources, and it can dynamically change between to-dos or users. At least hopefully it can. Let's check if it works. We'll change that to users. Looks like something went wrong there. Have I got, oh, I haven't got anything in this pre-tag. Let's say resources indexer dot, I'm just going to try restarting Volar because I should get auto completion there. Yeah, there we go, dot data dot value. And now we get users, change that to to-dos, index that again, and now we get to-dos. That's pretty freaking cool. And look how beautiful the code is to do that. Like, this is, to me, this is gorgeous. Now imagine adding on top of this some extra functionality. And by the way, as I was saying before, if you use classes for this kind of thing, you don't even need to define the type in there. You can actually set it up so you send through the class, and then that class might have entity on it. And this is what I do. I use Pina ORM, and then I use the entity field in order to know the endpoint that I'm hitting up. So you can send that through, it does the typing for you. But anyway, I want to keep this example simple. Another thing we can do is start accepting options. So if you have any filters in there, this is where it really comes in handy. You can say filters, and then that could also be a MaybeComputedRef. So you might say, for example, name is equal to Luke. Or you might want that to be a ref. So then you could have a ref like this with all of your filters in it. And there we go. And we'll call this const filters. I'm not going to actually code this for now, but I want to show you what's possible. And then you could send through as options in here your filters as a ref. And since this is a MaybeComputedRef, it's going to work if it's a ref, or if it's a string, or if it's a computed. Now let me show you, this is where a computed really comes in handy here. You could say, for example, const search is equal to, and we'll make that a ref. And now check this out. Let's take what we've got there and put that back in here, but we'll make filters a computed. So we're going to give that a function that returns our filters, which I had copied before. And instead of equal, maybe you can say like, I think sometimes they have like $Q is often what it's called. And we can go search dot value. Since this is a computed, we can use that ref. And now we could come down here and say q-input is equal to v model search, and we could put a label there equal to search, for example. And now, whenever we click on the index button again, it runs these, this gets resolved with resolve on ref, like I showed you before. And because it gets resolved every time it runs, every time it filters, this is actually dynamic. So we can now use search.value in there. Or we could just make that a computed that returns this, a string. Although the way I actually tend to do this though, is make search the object as a ref. So kind of like what I showed you before. This is how I like to do it. Getting lost in my code now. So you can just send through your filters directly like this. And then what I do is give that an empty string. See if I can get that done right. And now inside of the v model here, I would then say filters dot name dot $Q. So now we're modeling it directly on the filter. And since this is a MaybeComputedRef and it works with refs as well as static properties or computed, since it works with all of those things, this is now going to work dynamically. So all I have to do is define my filters ref, and then we can just model it here. And now when we click on index, it's going to automatically use that filter. How cool is that? Insanely cool is the answer. I really love using Vue's composition API. And when you use something like MaybeComputedRef, you really get this incredible amount of flexibility in your API. Now, let me quickly show you what this might look like, because I don't want to kind of just leave it there. We would need an options object in this case. I won't code the whole thing, but I'll just give you an idea. So then what you could do is you could say, I like to create lots of space in my code. Entity is the first thing. Options is the second thing. And we might have filters. And that would be a MaybeComputedRef. And you would, at this point, have to pass through typings for your typings for your filters. So you'd have to do all the typing work for what that filter looks like. So we can do that. We can send through our options. But let's just do an example of this, just to give you one more example. We could say immediate is equal to MaybeComputedRef, and then pass through a Boolean there. And now what we can do is say, if options.immediate, but we need to use resolve on ref on that, Okay, so if we resolve immediate and it ends up being true, then I want you to call index right away. So basically, we've created this API where we can do this. We can say, as a second parameter, so that's what our options is here. So options is this object I'm passing through as a second parameter. That should now be fully typed because we typed immediate here. So you should be able to say immediate, there it is. And I want that to be equal to true. And now look at what happens. Let's refresh this. Okay, it looks like I've put an error in here now. Let's try it again. Yeah, that gets called straight away because we had immediate set to true. But if we have it set to false, then it doesn't get called straight away. And this can be dynamic. And another thing we might want to do is say, so maybe when immediate is true, whenever the resource type changes, it automatically runs the request again. So what we can do now, I haven't actually tried this before, so let's see if this works. Well, what if we put a watcher on that? So we watch resolve unref immediate. Okay, and what happens? Sorry, no, that's not what I want to do. Let's go watch resolve unref entity. Okay, so if the entity changes, I want you to do something with that. I want you to, first of all, check if immediate is true. And if it is true, I want you to run index again. Okay, so let's have a look at that. Now, let's do that initial index. Oh, hang on, I didn't save immediate true. And now if I go to users, how cool is that? Woo! So now the moment we change that, it updates. And that's going to work with, yeah, so that works with a ref in this case, selected resource type. And let's just check if that would also work with a computed. All right, this is going to be a pretty contrived example, but we're just going to change that to a function that returns selected resource type.value. And I think that will still work. And it does. So I just wanted to prove to you there that because we're using resolve unref, we can send through a computed. And I want you to think, I keep saying computed here. We're sending through a function, but the reason I'm saying computed is because once again, that gets converted or that gets used as a computed behind the scenes, okay? So we're sending through a function that becomes a computed. It's just because this API is a lot easier to write than sending through computer like that. I actually don't know how this works, to be honest, but I'm guessing that what it might do behind the scenes is wrap it in a computer like this. I'm really not sure, but yeah, you get the point. And I think that's about it for this video. So this was a lot of fun. And you can imagine you could build similar composables for creating and updating and removing. And I really think that every business, or basically anybody who's building a web app, should put in the effort to building these composables and doing it with TypeScript. And maybe that means you create your own package with TypeScript types, and then you can use it in JavaScript. But writing it in TypeScript is just going to give you that extra typing. And if you really don't want to use TypeScript, then maybe you can just add annotations so that you still get a little bit of auto completion inside of your editor. But there you go. Yeah, I highly recommend, if you're doing any API requests, trying to build something like this so that you get that extra visibility into your application. It makes things so much easier to manage in the future. Honestly, looking back, I don't know how I used to write large applications without TypeScript and without the composition API. I remember it actually, it was a nightmare. Whereas these days, I can quite honestly say that I rarely feel overwhelmed when I'm coding, because I always know what my data looks like. Even when I'm tired at the end of the day, I always have an idea of the shape of my data. And this isn't because I'm particularly good at coding. And I really mean that. Like, I don't think that I'm naturally a great coder. I was just lucky enough to learn a lot of these skills. And it means that when I am coding in the real world, my brain's able to keep up. Like I don't consider myself to be someone that's, got a really fast brain or a brain that can hold a lot of things at once. I'm not really good at being able to understand and hold lots of concepts in my head at the same time. And because of that, because I'm not particularly good at that, and because some of the people on my team, tend to be new programmers, this helps a lot because it means that you can get away with less, just crap in your brain at the same time. So I hope you found this one useful. If you did, let me know in the comments, and I'll see you in a future video.